At the center of the Milky Way lies a realm hidden from ordinary sight, a place where starlight falters, where veils of interstellar dust cloak the truth in shadows. To peer into it is to strain against nature's own curtain, a theater concealed by cosmic smoke. Yet, behind that curtain, something stirs. It is the invisible puppeteer, pulling at stellar threads, dictating the rhythm of orbits across 40,000 light-years. Astronomers call it Sagittarius A*, but names barely capture the gravity of its presence. Too many. It is a monster cloaked in silence, 4 million times the mass of the sun, compressed into a space so small that not even light can escape. Around it, stars race in frantic loops, like sparks flung from a hidden forge. Their orbits reveal a truth the eye cannot, that a supermassive black hole beats at the heart of our galaxy. A cosmic heart pumping invisible power into the Milky Way's veins. We cannot see it directly, but its influence is undeniable. Every star in our spiral galaxy, every drifting cloud of gas, every comet wandering the void feels its pull. It is both executioner and creator, tearing matter apart, yet shaping the very architecture of the galaxy we call home. And so the question emerges, heavy with awe, what lies at the center of this great celestial wheel? Why does this hidden force, silent yet commanding, hold such sway over the vast kingdom of stars? The journey into the heart of the galaxy begins not with answers, but with the shiver of a mystery too great to ignore. In the early decades of the 20th century, the cosmos was still, to human eyes, a largely silent stage. Telescopes traced the luminous rivers of the Milky Way, mapping constellations, cataloging stars, and photographing nebulae that glowed faintly against the dark. Yet all of it depended on visible light, what the human eye, extended through glass and silver plates, could see. Beyond this narrow band of perception, the universe was whispering in frequencies unknown, carrying messages no ear was yet trained to hear. It was not an astronomer who first tuned in, but an engineer. In 1932, Carl Jansky, working for Bell Telephone Laboratories, sought to trace the origins of static that disrupted long-distance radio communication. With a 100-foot rotating antennaoid he called his mare ground, he swept the sky, noting the patterns of interference. What he found astonished him. The hiss was not earthly, nor atmospheric, nor solar. It repeated with the sidereal day, following the stars rather than the sun. The signal came from beyond the Earth, beyond the planets, from the heart of the Milky Way itself. It was the first whisper of the galactic center, a signal carried not in light but in invisible waves, veiled in frequencies long overlooked. Jansky himself called it star noise. The term was humble, almost dismissive, yet hidden. Within that noise was the first evidence of a power shrouded deep in Sagittarius. For a time, few followed. The 1930s and 40s belonged to war, to the harnessing of radio for communication and radar, rather than for listening to the heavens. But a lone figure persisted. Grote-Reber, an amateur radio engineer with the imagination of a pioneer. In his backyard in Wheaton, Illinois, he built the world's first parabolic radio dish. He mapped the radio heavens single-handedly, tracing arcs of invisible energy across the dome of night. Reber's maps revealed what Jansky had only hinted at, a galaxy alive with turbulence. bright in radio waves, where dust rendered it dark. To the eye, the center of the Milky Way was not silent at all. It blazed with activity, with clouds of electrons spiraling in magnetic fields, with storms of radiation unleashed by unseen engines. By the 1950s and 60s, radio astronomy matured into a discipline as new observatories rose across the globe. The giant dish at Jodrell Bank in England, the antennas at Green Bank in West Virginia, and instruments scattered across Australia began charting the skies with precision. It was here, in the constellation of Sagittarius the Archer, that a particularly bright and unruly region was revealed. Astronomers named it Sagittarius A, a designation as clinical as it was mysterious. Sagittarius A was no ordinary patch of the sky. It seethed with radio emission, a knot of turbulence where the galaxy seemed to concentrate its hidden power. As scientists traced its contours, they found its center flaring with peculiar intensity. As if a beacon pulsed beneath the interstellar shroud, the chase was on by the early 1970s. Astronomers had learned to peer deeper, to strip away noise, to focus their instruments on the very core of Sagittarius A in 1974, using the National Radio Astronomy Observatory's interferometer in Green Bank. Bruce Ballack and Robert Brown detected a compact, bright radio source buried in the heart of the region. They named it Sagittarius A*. The asterisk was no accident. It was a cautious mark, a symbol meant to denote peculiarity, something set apart from the rest. Yet in time, Sagittarius A* would become more than a curiosity. It would become the most studied object in the galaxy, the focal point of a mystery that had been whispering for decades. But in those early years, what was this tiny, bright source? Some suggested clusters of stars, packed impossibly tight. Others argued for exotic remnants, neutron stars or pulsars, compressed into swarms. Yet the scale was wrong, the density inconceivable. Calculations pointed to something darker, something far more extreme. The human story ran alongside the science. The researchers who chased these signals were explorers without maps, drawn not by light but by shadows. Jansky had stumbled on the first clue, only to see his career pulled elsewhere. Ballack and Brown, too, would see their discovery doubted as the scientific community wrestled with the implications. For to admit what Sagittarius A* might be was to admit the existence of monsters, black holes, not of stellar mass, but of millions of suns. The whispers grew louder with time. New techniques, sharper instruments, and persistent curiosity began to strip away the doubt. Infrared telescopes, capable of piercing the veils of dust, soon revealed stars whipping around an invisible center, moving at extraordinary speeds, their orbits betraying the hand of an unseen master. But that would come later. In the 1970s, the picture was still hazy, a sketch drawn in static and uncertainty. The galactic center had spoken in radio, and humanity had barely begun to translate its message. The discovery of Sagittarius A* was less a conclusion than a threshold, a doorway into a mystery vast enough to reshape cosmic thought. Behind the hiss of static, behind the maps of invisible light, behind the small asterisk marking a bright speck in Sagittarius, lay a revelation waiting to unfold. For now, it was only a whisper, a murmur of gravity and power, echoing across 26,000 light-years of space. But in that whisper was the promise of answers to questions older than humanity itself. What lies at the center of the galaxy? What unseen force binds the stars in their spiral arms? What truth waits at the heart of darkness? The journey had begun not with light, but with static, not with clarity, but with shadows. And through those shadows, a new chapter of human understanding was about to emerge. At the very center of the Milky Way, astronomers had found a source of invisible fire. In the familiar language of astronomy, light meant presence. Stars shone, nebulae glowed, galaxies sparkled in the black. Yet here, where the galaxy's gravitational heart resided, no star marked the spot. There was only a silence, invisible light, a void that radiated not brilliance, but obscurity. It was a puzzle that struck at the core of human expectations. The universe had always revealed its wonders through illumination, but now the brightest beacon in radio astronomy was also the darkest place in the sky. To comprehend the nature of Sagittarius A*, astronomers began comparing what they saw, what they did not see. The radio emissions flared with intensity, yet when optical telescopes were trained on the exact coordinates, no luminous body answered. The absence was not merely puzzling, it was profound. Something occupied this space, something compact, powerful, and invisible. Calculations began to sketch a portrait. The energy released implied enormous mass. The scale of its influence stars, orbiting near the galactic center with startling velocity, spoke of gravity far beyond what any cluster of ordinary stars could produce. Gradually, the estimates converged. 4 million times the mass of the Sun, confined to a region no wider than the orbit of Mercury. It was a density that defied the imagination. Entire stellar generations, millions of suns, collapsed into a single point of gravitational fury. No gas cloud, no swarm of neutron stars, no exotic cluster could account for such confinement. The only solution, though long resisted, now demanded attention. Sagittarius A* was not a star at all. It was the shadow of a black hole. The term itself was young. Only in 1967 had physicist John Wheeler popularized black hole to describe the end state of massive stars, objects so dense that not even light could escape their grasp. Before Wheeler, the idea lived only in the mathematics of general relativity, a curious possibility sketched by Einstein's equations but long dismissed as unphysical. A grotesque fiction born of mathematics alone. Yet here, at the heart of the Milky Way, fiction began to harden into fact. Einstein himself had hesitated. General relativity, unveiled in 1915, predicted that gravity could warp space and time, bending them into geometries beyond ordinary comprehension. In 1916, Carl Schwarzschild, calculating from the trenches of the First World War, derived a solution that described a point of infinite density, wrapped in a one-way horizon. It was the first glimpse of what would later be called a black hole. But to Einstein, the notion was troubling. He suspected nature would forbid such extremes. For decades, the idea lingered at the edge of physics, tolerated but unproven, a strange artifact of mathematics with no confirmed reality. Black holes were thought to be curiosities, mathematical monsters, not entities that galaxies would host in their cores. Sagittarius A*, shattered that comfort. The evidence mounted through the 1970s and 80s. Radio interferometers grew sharper. Infrared detectors began to cut through the veils of dust, revealing not a star at the center, but stars around it, moving in frantic arcs, their orbits betraying an unseen presence. Their speeds implied a gravitational anchor so concentrated that no ordinary matter could explain it. The invisible mass demanded recognition, a black hole not of stellar mass, but of millions of suns. The shock was not merely scientific, but philosophical. For centuries, the center of the universe, whether Earth, the Sun, or the galaxy itself, was expected to be a place of brilliance, a throne of light. Yet here, at the heart of the Milky Way, sat not radiance, but darkness, not a star, but an abyss. Astronomers wrestled with the paradox. Could the very structure of the galaxy be built around emptiness? Could a void, cloaked in silence, be the master of hundreds of billions of stars? Evidence left little room for denial. Every observation pointed to the same unsettling conclusion. The orbits of stars, the compactness of the source, the sheer density required peace pressed harder against doubt. Sagittarius A*, was the cosmic predator at the center of the spiral, a black hole of supermassive scale. The paradigm shifted. Black holes, once whispered of as mathematical ghosts, now stood revealed as the central architects of galaxies. They were no longer the rare, tragic end of dying stars. They were engines of creation and destruction, shaping the universe on the grandest scales. In the human imagination, this revelation cut deep. The heart of the Milky Way, placed toward which every star in the night sky slowly turns, was not filled with light, but with absence. Where one might expect a jewel, there lay a chasm. Where one might hope for a cosmic lantern, there was only the maw of gravity. And yet, in this darkness, there was also a strange kind of order. The stars obeyed its pull with unwavering loyalty, tracing paths that only gravity's law could demand. The galaxy's spiral arms unfurled around it, like the whirls of a great seashell centered on silence. Out of this absence, form itself emerged. This was the shock of Sagittarius A*, the realization that the core of the Milky Way, and perhaps every galaxy, was not a fountain of radiance, but a well of shadow, a starless abyss, dense beyond measure, hidden behind dust, yet felt across light years. From Jansky's static to Reber's maps, to the compact flare, Ballack and Brown, named with an asterisk, the trail of evidence had grown undeniable. The whispers had become a voice. The unseen had begun to declare itself. The age of the black hole had begun. For decades, a void, invisible light, an enigma wrapped in the dust of the Milky Way. Scientists suspected a monster at its heart, but suspicion alone could not overturn centuries of certainty. At the European Southern Observatory in Chile, and at the Keck Observatory atop Mauna Kea in Hawaii, astronomers built instruments of unprecedented sharpness. These telescopes, armed with adaptive optics to tame the trembling of Earth's atmosphere, pierced the dust and turbulence that veiled the galactic center. With them, the core of Sagittarius was no longer a blur. It became a stage, and on that stage, stars performed a celestial ballet. Among them was one star in particular, S2. To the naked eye, it was nothing more than a speck, hidden behind veils of interstellar gas. But through the patient gaze of infrared telescopes, S2 revealed itself as a key witness to the invisible. Its orbit was extraordinary, an ellipse that swung it perilously close to the galactic abyss, only to fling it back into wider arcs. It completed this journey in just 16 years, racing at speeds exceeding 7,600 kilometers per second. When closest to the center, Andrea Ghez, leading a team at UCLA, and Reinhard Genzel, guiding his own at the Max Planck Institute, devoted decades to following S2 and its companions. Year after year, night after night, they plotted positions with painstaking care, watching the stars curve around nothing. The orbits drew invisible lines, tracing the presence of a force that could not be denied. And what those lines revealed was staggering. All of the mass 4 million suns worth was confined within a region no larger than our solar system. It was not spread across a cluster of stars, nor a cloud of gas. It was compressed to a point of near infinite density. No object other than a black hole could account for such concentration. S2, single quotes, S journey, became a Rosetta Stone for the galactic center. At its closest approach, it passed within just 17 light-hours of Sagittarius A*, distance barely 4 times that between Neptune and the Sun, and yet around that empty space, the star did not collide, did not scatter, but instead obeyed the unyielding pull of gravity's most extreme form. Here was the confirmation long sought. The invisible force was not theoretical. It was measurable, charted in the sky like the sweep of a cosmic pendulum. The black hole at the galaxy's core was no longer conjecture, it was fact. The implications rippled outward. Einstein's general relativity, once tested only in the relatively tame environments of the solar system, was now being pushed to its limits. The paths of S2 and other stars revealed the warping of spacetime itself. When S2 swung close to Pericenter in 2018, astronomers watched its light stretch and redden under the strain of gravitational time dilation, precisely as Einstein's equations predicted. In the distortion of a single star's light, humanity glimpsed the bending of time itself. And yet, the spectacle was not just mathematical. It was profoundly human. To watch S2 dance was to watch a star risking annihilation, tracing an orbit beside the edge of the abyss. Each close pass carried it to the very brink, where a misstep could plunge it forever beyond the event horizon. Its survival, its repeated return, was both a reassurance and a reminder of the delicate balance that held galaxies together. Other stars joined the performance. Dozens were tracked, each orbit adding to the weight of evidence. Together, they painted the same portrait, a gravitational anchor of 4 million solar masses compressed into darkness. The galactic dance carried tension, for at its heart was a paradox. Gravity was the sculptor, but here it sculpted with absence. It held stars in orbits, defined spirals, commanded order, and yet the source of that gravity could not be seen. The very thing that organized the galaxy was invisible, cloaked in a silence deeper than night. For scientists, this tension was revelation. Black holes were no longer exotic ends to dying stars, scattered sparsely across the cosmos. They were central engines, the keystones of galaxies. The Milky Way, the vast spiral that cradled the Earth, owed its shape, its order, its very identity to a hole in space-time. The observations also raised questions that deepened the mystery. How had such a behemoth formed? Had it grown from the collapse of primordial stars, or from the mergers of smaller black holes? Was it feeding still, swallowing gas and stars that strayed too near? Or was it dormant, a sleeping predator awaiting the next feast? Every answer seemed to widen the abyss. The dance of the stars proved the black hole's existence, but it also reminded humanity of its ignorance. For all that was measured, the orbits, the mass, the density, the heart of Sagittarius A asterisk remained unseen. The event horizon itself, the edge where space and time dissolve into singularity, lay just beyond reach. Still, the stars kept circling, patient messengers of a truth larger than themselves. Their arcs across decades of observation became a bridge between theory and reality. They showed that even in the most chaotic regions of the galaxy, order prevailed not by chance, but by the hand of gravity's ultimate expression. The work of Gez and Genzel was not merely technical, it was generational. It demanded persistence. Across years, when data was scarce, when the technology was imperfect, when the signal was drowned in dust, it demanded belief that patience itself was a tool of discovery. Their reward, and the world's, was a vision of the galaxy's heart, unveiled not in light, but in motion. In 2020, the Nobel Prize in Physics was awarded to both teams for their work. It was a recognition not only of proof, but of perseverance. For, in the orbits of stars, humanity had at last confirmed what whispers and shadows had long suggested. At the center of the Milky Way, a supermassive black hole waits in silence, commanding the galaxy like an unseen king. The dance continues. Still, stars circle, some slowly, others in frantic dashes, each one obeying laws older than time. Around them, the galaxy spins, a spiral of light tethered to a point of darkness. And in their motions lies a truth both humbling and profound, that the universe is not ruled by brilliance alone, but by forces invisible, forces that bend light, warp time, and define the stage upon which all cosmic drama unfolds. Sagittarius A asterisk is no longer a whisper, no longer a conjecture. It is the cosmic heart of the Milky Way, and its dance, traced in the arcs of stars, is the music by which the galaxy turns. For years, the galactic center was treated as a silent titan immense, immovable, invisible. Sagittarius A asterisk had been confirmed as a supermassive black hole. But in those early portraits, it appeared dormant, a gravitational anchor, asleep at the galaxy's heart. Its presence was undeniable, but its activity seemed muted, as though the abyss had chosen quietude. Then came the light of new eyes. Launched in 1999, NASA's Chandra X-ray Observatory was designed to capture the highest energy photons, the X, born in cosmic furnaces of unimaginable heat. When its instruments turned toward Sagittarius A asterisk, silence was replaced with drama. For out of the darkness, the black hole flared. Sudden bursts of X-ray light blazed from the galactic center, each lasting a few hours before fading again into obscurity. The source was unmistakable, Sagittarius A asterisk. These flares, millions of times brighter than the sun in X-rays, betrayed the monster's hunger. Material gas, clouds, dust, Perhaps even asteroids had strayed too close, heating to tens of millions of degrees as it spiraled inward before crossing the event horizon and vanishing forever. The flares were the death cries of matter, the final flash before silence. Infrared observatories added their own testimony. In 2003, astronomers at the European Southern Observatory detected near-infrared flares erupting from Sagittarius A asterisk. These bursts often coincided with the X-ray storms, weaving a tale of sporadic feeding. The black hole was not fully dormant, fed in fits and starts, swallowing morsels in the shadows. The revelations reframed the monster. It was not a passive anchor, but a predator with moods. Most days it slumbered, but when food arrived, gas clouds brushing too near, magnetic fields tangling, debris crossing invisible thresholds, it awakened in brief, violent flashes. These were not the steady beacons of a star, but unpredictable heartbeats, reminding observers that the abyss was alive. Yet these whispers of hunger were only the surface. Astronomers began to search for deeper scars traces of the black hole's ancient history. X-ray surveys revealed ghostly echoes reverberating through the Milky Way's central regions. Vast clouds of gas, tens of light years across, glowed faintly in reflected X-rays. They seemed to shimmer, not from their own energy, but from radiation long past, like smoke catching the memory of fire. These were the aftershocks of ancient eruptions, the echoes of Sagittarius A asterisk when it had been far more active. Indeed, the evidence grew that our black hole was once a quasar, blazing with the brilliance of 1 trillion suns, billions of years ago. In the youth of the galaxy, Sagittarius A asterisk may have gorged on torrents of gas, its accretion disk shining so brightly it could have rivaled entire galaxies in luminosity. The faint light reflected today in gas clouds and dust lanes may be the dying echoes of that era of violence. And there were larger scars still. In 2010, scientists analyzing data from the Fermi Gamma Ray Space Telescope discovered 2 vast lobes of energy ballooning above and below the plane of the Milky Way. Each structure, now called the Fermi bubbles, stretched 25,000 light-years into space, dwarfing the galaxy's disk. Their origin remained mysterious, but many suspected Sagittarius A asterisk as the architect. Perhaps millions of years ago, the black hole had unleashed a colossal outburst, spewing energy outward in twin jets that carved the galaxy's halo. If true, it meant the Milky Way's heart had once erupted with fury equal to quasars in distant space. What was revealed was not just a black hole, but a history of cycles, quiet epochs, punctuated by violence. Today we see Sagittarius A asterisk in a low state, feeding sparingly, producing only modest flares. But the scars around it speak of another time, when its appetite was vast, its radiance unbearable. The question lingered, could it awaken again? Gas clouds, drifting through the galactic center, offered ominous hints. In 2011, astronomers identified a cloud, later named G2, on a collision course with Sagittarius A asterisk. By 2014, it grazed the black hole, and many expected fireworks. Would the monster flare with renewed hunger? Would its dormant blaze rekindle? The event proved quieter than anticipated, but subtle brightening was observed. G2 may have been stretched and shredded, feeding the abyss in smaller morsels than imagined. Still, the episode was a reminder that Sagittarius A asterisk is not finished. Its quiet today is not a guarantee of silence tomorrow. A single massive cloud, or the misfortune of a wandering star, could transform the heart of the Milky Way into a quasar once more, flooding the galaxy with radiation. For humanity, this realization carries both wonder and humility. The stars we see in the sky, the spiral arms that cradle our solar system, all turn around a nucleus capable of violence beyond imagination. Our galaxy lives in the shadow of a monster slumbering, but restless. Yet, there is poetry in this as well. Without such black holes, galaxies might never have formed as they did. Their violent outbursts regulate the birth of stars, stirring gas, shaping structures, even setting the tempo of cosmic evolution. Sagittarius A asterisk is not just a predator, is also an architect. Its flares and explosions are both destructive and creative, sculpting the Milky Way into the home we now inhabit. To study its outbursts is to read the biography of our galaxy's heart. Chandra's X-ray flares, infrared flashes, and gamma-ray scars are all chapters in that history. They remind us that the abyss is not empty, but dynamic, not silent, but singing in wavelengths our eyes cannot see. And as we peer deeper, with sharper instruments and longer patience, the mystery deepens. For each flare, each echo, each scar, whispers of both past and future. What we witness today may be but a lull between storms. At the center of the Milky Way lies a starless abyss. Yet it is not barren. It is a heart that beats in bursts of fire, a predator that sleeps with one eye open, a memory of violence written across tens of thousands of light years. Sagittarius A asterisk is revealed not only as a black hole, but as a story. In motion, a story of hunger, silence, eruption, and rest. A monster cloaked in darkness, yet luminous in its scars. A force that has shaped the galaxy, and may one day awaken to shape it again. The revelation is sobering. The Milky Way's calm beauty, its spiral grace, its scattered fields of stars, all orbit a creature of unimaginable power. A creature that once blazed like a quasar, and in time may blaze again. The heart of the Milky Way is not simply a black hole, it is a question. Sagittarius A asterisk, for all that has been revealed, remains a paradox wrapped in gravity's deepest silence. To look at it is to look not merely at an astronomical object, but at a crossroad where physics, cosmology, and philosophy converge. For what truly lies at the center of the abyss? Is it a graveyard for fallen matter? Or could it be something stranger, doorway, a seed, perhaps even a gateway to realities beyond our own? The search for answers begins with what can be known, with the mechanics of the abyss itself. The event horizon, a one-way Velevary black hole, is defined not by what can be seen, but by what cannot. The event horizon is the surface of no return, a spherical veil where escape velocity equals the speed of light. For Sagittarius A asterisk, this radius known as the Schwarzschild radius measures about 12 million kilometers. In cosmic terms, it is small, barely larger than the orbit of Mercury. And yet, within this modest boundary lies the compressed weight of 4 million suns. The event horizon is not a physical surface. It is a horizon in the truest sense, a limit of observation, a line beyond which no information can cross. Matter and light that pass this threshold do not strike a wall, they simply vanish from the observable universe, their histories cut short, their future hidden from all but the abyss itself. To an outside observer, infalling matter never quite crosses. Time slows under gravity's hand, and as an object approaches the horizon, its light redshifts, fading toward darkness until it freezes at the edge. But from the object's own perspective, time flows normally, and the crossing happens in an instant. The paradox is profound, a place where different perspectives describe different realities, both equally true. The singularity, a place where physics breaks at the center of every black hole, lies the singularity, the end point where equations collapse. According to general relativity, mass inside a black hole is crushed into infinite density at a single point. Space and time themselves curve into a place where the known laws of physics lose meaning. For Sagittarius A*, the singularity is hidden beneath 26,000 light-years of distance and an impenetrable horizon. Yet its existence is both terrifying and tantalizing. Infinite density is not a physical description, it is a confession of ignorance. It signals where Einstein's theory fails, where quantum mechanics must intervene, and where a new understanding of space-time awaits. Discovery is the singularity truly a point of infinite compression? Or is it instead something else's structure, veiled by dimensions beyond our comprehension? In its shadow lies the frontier of modern physics, where relativity and quantum theory must one day reconcile. The accretion disk, a halo of firewire, the singularity is hidden. Its influence can be seen in the matter it devours. Gas and dust, spiraling into Sagittarius A*, do not fall directly inward. A whirlpool of plasma heated to millions of degrees by friction and magnetic fields. This disk glows in X-rays and infrared, lighting the darkness with brief, violent flares. Jets of particles may erupt from its pores, driven by twisted magnetic lines. Though Sagittarius A*, today is relatively quiet compared to the blazing quasars in distant galaxies, the accretion disk is more than decoration. It is a cosmic laboratory. Within its whirling plasma, matter is torn apart, atoms stripped, energy unleashed in torrents. It is here that the boundary between consumption and creation is blurred. For while the black hole feeds, it also radiates, shaping the environment of the galaxy. Black holes and the architecture of galaxies. One of the most profound questions is whether black holes, like Sagittarius A*, are mere byproducts of galaxies, or their architects. Every large galaxy studied so far harbors a black hole at its core. Moreover, there is a striking correlation between the mass of the central black hole and the mass of the galaxy's bulge. This relationship suggests a deep, perhaps causal, connection. Did Sagittarius A*, form after the Milky Way, growing by stars and gas as the galaxy matured? Or did it exist first, a seed around which the spiral arms coalesced? Some models suggest the latter, that in the early universe, massive black holes formed rapidly, either from collapsing primordial gas or from the mergers of the first stars. These then acted as gravitational anchors around which galaxies accreted. In this view, Sagittarius A* is not merely a passenger in the Milky Way's journey, but the nucleus around which our cosmic home crystallized. If true, it means that without the abyss, there might be no galaxy at all, land, no Earth to ask the question. Theories beyond the known. The abyss also invites speculation that borders on the fantastical, yet remains grounded in real physics. Wormholes, gateways through spacetimes, some solutions to Einstein's equations suggest that black holes could connect to wormholes, bridges through spacetime linking distant regions of the universe, or even different universes entirely. Could Sagittarius A asterisk be not just a graveyard, but a doorway? The mathematics is tantalizing, but unstable. Wormholes, if they exist, may collapse instantly, or require exotic matter with negative energy to remain open. Still, the idea persists, for it offers a vision of the abyss, not as an end, but as a passage. The firewall paradox in quantum physics. Information cannot be destroyed. But if matter falls into a black hole and vanishes, where does its information go? One radical proposal is the firewall paradox, that instead of passing smoothly through the horizon, matter encounters a wall of searing energy, where information is somehow preserved. If true, Sagittarius A asterisk is not simply a silent trap, but a place where the deepest principles of reality, information, entropy, the arrow of time are rewritten. The quantum information puzzle. Another theory suggests that information may be smeared across the horizon itself, encoded in quantum fluctuations, then radiated back out in subtle ways. This connects to Hawking radiation, the theoretical process by which black holes slowly evaporate over eons. Though Sagittarius A asterisk is far too massive to evaporate within the lifetime of the universe, the theory raises a profound question. Does the abyss truly erase, or does it remember in ways we cannot yet detect? Dark matter and the galactic core, the heart of the Milky Way, is also a laboratory for another cosmic mystery. Dark matter. This invisible substance outweighs ordinary matter 5-1, sculpting galaxies with its unseen gravity. Some theories suggest that black holes may interact with dark matter, perhaps even anchoring its distribution. Could Sagittarius A asterisk be surrounded by a cusp of dark matter, feeding invisibly on a substance we cannot yet detect? Could the growth of black holes and the structure of dark matter halos be linked? If so, then to understand Sagittarius A asterisk is also to approach the riddle of dark matter, the hidden scaffolding of the cosmos. Philosophical speculations. Graveyard or gateway. Beyond physics lies philosophy. What does it mean that the center of the galaxy, the place toward which every star in the night sky slowly turns us a void, is Sagittarius A asterisk a graveyard, the ultimate end of matter, where stars, planets, and histories vanish into silence? Or could it be a gateway, a place where what is lost here is reborn elsewhere, beyond our horizon of understanding? Perhaps the truth is both. To us, the black hole is an end. To the cosmos, it may be a beginning. In the collapse of stars, the eruption of quasars, in the shaping of galaxies, the abyss is both executioner and midwife. For humanity, it is also a mirror. To confront Sagittarius A asterisk is to confront the limits of knowledge itself. It shows where our theories fracture, where our imagination strains, where mystery remains sovereign. It is the heart of our galaxy, but also the edge of our understanding. A cosmic invitations, Sagittarius A asterisk is not merely an object of study, is an invitation. It calls scientists to build sharper instruments, to test deeper theories, to reconcile quantum mechanics with relativity, to listen for whispers of dark matter, to seek echoes of ancient quasars. It also calls poets and philosophers, for its darkness is as much a question of meaning as of mechanics. In its silence, it asks, what does it mean to live in a universe where the heart of our home is an abyss? Perhaps one day physics will peer past the event horizon. Perhaps one day theory will reveal what lies at the singularity. Until then, Sagittarius A asterisk remains what it has always been, a mystery written in gravity, a question carved into the stars, a graveyard gateway, a heart of darkness. And yet, from that darkness, the Milky Way shines. For centuries, humanity studied the heavens with the only tool it possessed, the eye. Later, lenses sharpened its reach, mirrors extended its grasp, and detectors expanded its sight beyond visible light. Yet there remained one frontier that resisted all efforts, the heart of the Milky Way, where Sagittarius A asterisk hid in silence, cloaked in dust, invisible to optical vision. It was a mystery too vast for any single telescope to reveal. To see the unseeable, astronomers would need to reshape Earth itself into an eye. The Event Horizon Telescope, a planet-sized lens in 2022. After decades of preparation, the Event Horizon Telescope unveiled the first image of Sagittarius A asterisk. It was not a crisp portrait in the style of ordinary astronomy. Instead, it was a ring, a luminous halo of bent light encircling a shadow. The fiery glow marked matter on the brink of consumption, while the dark center revealed the presence of the event horizon itself. The image was the culmination of one of the most ambitious collaborations in scientific history. The Event Horizon Telescope is not a single instrument, but a network of observatories scattered across the globe, from the high deserts of Chile to the frozen summit of Mauna Kea, from the Sierra Nevada of Spain to the South Pole itself. By linking them together through a technique called very long baseline interferometry, scientists created a telescope the size of Earth. Interferometry is a symphony of precision. Each observatory records signals of radio waves arriving from Sagittarius A asterisk, but the signals alone are incomplete. Only when combine timed with atomic clocks accurate to a billionth of a second do they form a coherent image. Data flown by hard drives across continents is woven together like threads in a cosmic tapestry, revealing structures finer than any single telescope could resolve. The challenge was monumental. Sagittarius A asterisk is smaller on the sky than a grain of sand seen from thousands of kilometers away. Worse still, the matter around it shifts constantly, flaring and fading on timescales of minutes. To capture such a restless target required patience, algorithms, and the steady work of hundreds of scientists across the globe. When the image was finally revealed, it was a watershed moment. For the first time, humanity had not just inferred, but seen the shadow of the Milky Way's black hole, a ring of fire around a darkness absolute. It was more than a picture, it was proof. Proof that Einstein's general relativity still held. In the most extreme gravitational laboratory known, proof that the monster at the center of the galaxy was exactly what decades of whispers had suggested. Yet even this triumph is only a beginning. The next frontier, listening to Gravity 2 probe. Deeper, humanity must move beyond light. For light, even bent by gravity's hand, is still limited by the veil of the horizon. What passes inside is lost. But gravity itself ripples outward in waves in the coming decades. The Laser Interferometer Space Antenna Lissel, Take 2. The skies, composed of 3 spacecraft flying millions of kilometers apart in a triangular formation. LISA will measure the faint stretching and squeezing of spacetime itself. These are gravitational waves, ripples born from cataclysms like black hole mergers, neutron-star collisions, and perhaps even the subtle quivers of Sagittarius A asterisk. Unlike ground-based detectors such as LIGO and Virgo, LISA will listen to longer wavelengths, sensitive to the slow, titanic dances of supermassive black holes. It will open a window not to starlight, but to the very heartbeat of gravity. Should Sagittarius A asterisk ever merge with another giant, LISA will hear its song across billions of light years, a deep, resonant echo of spacetime itself. Even without such an event, the observatory may detect background hums of gravitational energy, whispers of cosmic processes hidden since the dawn of galaxies. In listening to gravity, humanity will not merely observe, the abyss will hear its voice, X-ray eyes, Athena, and the violent universe, while gravitational waves promise to reveal the hidden choreography of black holes. X-rays expose their violence. Hot plasma, spiraling in accretion disks, glows with energy so fierce that only specialized instruments can detect them. The European Space Agency's upcoming mission, Athena, the advanced telescope for high-energy astrophysics, will provide the sharpest X-ray vision ever built. Scheduled for launch in the 2030s, Athena will watch the flares of Sagittarius A asterisk with unprecedented detail, mapping their rise and fall, studying how matter is shredded by tidal forces and how magnetic fields twist near the event horizon. Athena will also search for relics of ancient eruptions, examining the faint afterglow of past violence, written in gas clouds and galactic structures. Its eyes will trace the scars of Sagittarius A asterisk's history, reconstructing the biography of a monster across millions of years. Together with Chandra, which first caught Sagittarius A asterisk's flares, and the Japanese XRISM mission, Athena will ensure that the abyss is never silent to X-ray ears. The Square Kilometer Array, a radio revolution beyond the skies. Another colossus is rising. The Square Kilometer Array, SKA, the largest radio observatory ever conceived, spread across South Africa and Australia. Its thousands of antennas will together form a radio eye vast enough to map the faintest whispers of the cosmos. For Sagittarius A asterisk, SKA will measure turbulence in its environment, track magnetic fields, and refine the structure of its radio emission. More profoundly, it will map pulsars near the galactic center, rapidly spinning neutron stars that act as natural clocks. By observing how their signals are delayed and warped by the black hole's gravity, astronomers will test general relativity in regimes never before explored. Where the Event Horizon Telescope offered an image, the SKA will provide a chronicle, a constant watch over the radio heartbeats around the abyss. Quantum shadows, and particle physics. But the black hole is not only an astronomical puzzle, it is a crucible where particle physics and quantum mechanics are forced to confront gravity itself. Stephen Hawking's revolutionary insight in 1974 suggested that black holes are not entirely black. Through quantum effects at the event horizon, they radiate faintly, losing mass over inconceivably long timescales. For a black hole as massive as Sagittarius A*, the evaporation time is greater than the current age of the universe by a factor of a trillion. Yet the principle is profound. Black holes are not eternal. This raises the quantum information paradox. If matter falls in, where does its information go? Quantum theory insists it cannot be destroyed. Does the horizon encode it, as the holographic principle suggests, projecting the three-dimensional contents of the universe onto a two-dimensional surface? If so, then Sagittarius A* is not just a graveyard, but a cosmic library, where every particle that has ever crossed the horizon is etched in patterns of quantum fluctuation. These ideas remain speculative, yet they hint at a radical truth that black holes may be the key to unifying quantum mechanics and gravity, the two great but incompatible pillars of physics. In the darkness of Sagittarius A*, may lie the blueprint of a future theory of everything. Humanity's attempt to measure the immeasurably at the core of all these efforts is a paradox of ambition. Humanity is finite, fragile, and small. The black hole at the center of the Milky Way is distant beyond imagining, vast beyond comprehension, and concealed behind the limits of physics. And yet, piece by piece, humanity measures it. Atomic clocks, radio interferometry, X-ray detectors, spacecraft spread across millions of kilometers all combine to probe the unprobable. The Event Horizon Telescope captured its shadow. Chandra revealed its flares. Fermi unveiled its ancient scars. Soon, Lisa will hear its gravitational voice. Athena will trace its violent plasma, and SKA will map its whispers. Each tool sharpens the picture. Each mission pushes the horizon of understanding further into the abyss. What emerges is not only knowledge of a black hole, but a portrait of humanity itself, curious, patient, unwilling to accept mystery without pursuit. A mirror of human wonder. Sagittarius A* is, at its essence, a challenge. It defies sight. It warps time. It conceals information. It swallows light. Yet, in every defiance lies an invitation to build better telescopes, to refine deeper theories, to imagine boldly, and to test relentlessly. It is more than an object. It is a mirror. In its shadow, humanity sees its own reflection, a species that refuses to be content with darkness, that strives to illuminate the void, even when the void is infinite. The tools we build to study Sagittarius A* are not just machines of science. They are monuments to wonder. Earth itself has been turned into a telescope. Space will soon be transformed into a gravitational ear, and the future will carry instruments capable of seeing further than imagination once dared. The attempt may never be complete. The singularity may remain forever veiled, the horizon forever closed, but the pursuit itself is the meaning. To measure the immeasurable is to define what it means to be human, and so, at the center of the Milky Way, the abyss waits. A shadow encircled by light, a silence punctuated by flares, a paradox that deepens as each new tool peels away a layer of mystery. The monster is revealed, yet never fully, for the more we probe the darkness, the more it reminds us the universe is greater than the sum of its discoveries. Sagittarius A** is not the end of the story. It is the beginning of the next chapter of human curiosity. At the center of the Milky Way lies silence. Not the silence of peace, but the silence of consumption. Sagittarius A** is not a star that radiates, nor a beacon that gives. It is a devourer, a place where light itself is erased, where matter is stripped of identity, where time collapses into oblivion. This is the paradox at the heart of our galaxy, the center of the spiral. The anchor of billions of suns is not a fountain of brilliance, but a well of darkness. For most of human history, the universe was imagined as harmonious, even benevolent. The sun nourished Earth with warmth. The stars sprinkled beauty across the sky. The heavens were regarded as serene, but the discovery of black holes shattered that illusion. The cosmos is not built solely on radiance, it is built equally on absence, on voids that consume, on abysses that shape without shining. And so we face the unsettling truth. The galaxy's center is not a giver, but a taker. The heart of our cosmic home is not a lantern, but a grave. Civilizations orbiting a monster. Consider what this means for us. Every star we see in the night sky, every planet that harbors the possibility of life, every civilization that may look upward from distant worlds, all orbit a monster. Each is bound to a predator 26,000 light-years away, circling endlessly around a gravitational abyss. It is a sobering vision that life, fragile and temporary, exists in the gravitational embrace of something that erases. The cradle of civilizations is tied to a devourer. The great architectures of culture, thought, and history all unfold within a galaxy whose beating heart is silence. From a cosmic perspective, this truth humbles. The Earth, with all its mountains and oceans, its wars and wonders, is a mote of dust caught in a spiral around an abyss. Our achievements, the voyages across oceans, the exploration of space are fragile sparks, flickering under the gaze of a gravity that has persisted for billions of years and will persist long after we are gone. And yet, it is not only humbling, it is also astonishing. For, against this backdrop of silence, life has dared to bloom. Consciousness has arisen on a small blue planet. Fragile instruments have been built. And with those instruments, we have done the unthinkable. We have looked into the abyss itself. Fragile instruments, infinite reach, the paradox deepens. The black hole consumes without end. Yet we, small and finite, have reached across light years to measure it. With mirrors no larger than a classroom, with radio dishes scattered across deserts and mountaintops, with detectors cooled to near absolute zero, we have mapped the motions of stars that race around nothing. We have captured the glow of matter. Moments before annihilation, we have stitched the Earth into a telescope to photograph the shadow of the abyss. The fragility of these instruments contrasts with the enormity of their target. Sagittarius A* is 4 million times the mass of the Sun. Our telescopes tremble at the push of wind. Yet it is through such fragility that we have glimpsed the most unyielding force in nature. This is a testament not just to science, but to humanity itself. We orbit a monster, yet we refuse to be its victim. We measure it, we name it, we dare to imagine its mechanics, its past, its future. In the act of observation, we assert meaning against the void. The double nature of the abyss. What then is Sagittarius A asterisk to us? Is it a threat, or is it a foundation, a destroyer, or a creator? The answer is both. Without the black hole, the Milky Way might never have formed as it did. Its gravitational pull has held the galaxy together. Its outbursts have regulated the birth of stars. Its presence has defined the spiral structure that cradles our solar system. The abyss is not only destructive, it is architectural. It shapes as much as it erases. This is the paradox of the universe. Creation and destruction are not opposites, but partners. The same gravity that consumes stars also sculpts galaxies. The same abyss that erases matter provides the order that allows life to exist at all. In this sense, Sagittarius A asterisk is not just a graveyard. It is also a womb. It is a silence that has made music possible, an absence that has allowed presence to emerge, fragility and greatness for humanity. This paradox becomes a mirror. We are fragile, temporary, vulnerable to forces far beyond control, and yet we are also great, with thought, with imagination, with instruments of glass and metal. We have probed the unprobable. We live in a fragile universe. Stars exhaust their fuel, galaxies collide, black holes devour. But within this fragility arises meaning. Fragility is not weakness, it is the condition that allows beauty. Just as the cherry blossom is beautiful because it fades, so too is consciousness precious, because it arises against the darkness. The fragile universe does not diminish us, it defines us. A philosophical reflection. And so the question remains, what does it mean that the heart of the galaxy is a black hole? It means that the universe is not made to comfort. It is not designed for human eyes, nor built to satisfy human hopes. It is indifferent. The heart of the Milky Way devours, not because it is cruel, but because it is what it is. Yet, in that indifference, humanity finds purpose. To confront the abyss is to confront the limits of knowledge, and still to press forward, to accept that the galaxy's center is darkness, and yet to orbit it with life, with thought, with art, is to create meaning where none is given. Perhaps this is the deepest truth the black hole offers, that even in a universe whose center is silence, life can speak. A final note: Sagittarius A asterisk is not merely destruction, it is structure, it is order. Without it, there may be no Milky Way. Without the Milky Way, no sun. Without the sun, no earth. Without earth, no humanity. To ask these questions, the monster defines us, not only by what it consumes, but by what it allows to exist. Its gravity, its violence, its silence all have shaped the galaxy into the cradle we call home. In the end, the black hole at the center of the Milky Way is not just the end of stars, but the condition of our beginning. It is both grave and womb, silence and song, absence and foundation. We orbit a monster, but without the monster, we would not exist. This is the fragile universe, a cosmos where life arises beside voids, where meaning emerges in silence, where fragile creatures on a fragile world can gaze into darkness and see themselves reflected, and in that reflection lies both humility and greatness. The heart of the Milky Way is darkness, but because of it, the galaxy shines.